right, so can you please let me know on the chat if you are back, please? Can you please let me know on the chat if you are back? Okay, very good. Very good. All right, let's continue with our slides. All right. We spoke about the infrastructure, and now it's time to go through the products and services benefits that we can have from AWS. So AWS products and services, we are going to go through the coming few slides about the families of products that we have and what do we have inside each and every family. So we're going to talk about compute. We're going to see what kind of offerings we have from AWS on the compute part, on the storage part, on the database, security, management, governance, and finally on the networking. So let's see one by one. So the first one is the compute services, right? And if we want to start with the compute services, the easiest one we have is what we call EC2. What is the EC2? EC2, very simply, this is a virtual server on the cloud. And we have multiple options of EC2 instances. So for example, we can have a Linux EC2 instance with all the flavors of Linux. We can have a Windows EC2 instance with the multiple option of Windows servers, for example. You can have a Mac EC2 instance. So very simply, EC2, or what we call Elastic Cloud Compute, and that's why it's called EC2, because it's Elastic Cloud Compute. And here, this is the virtual server that I have on the cloud. And you can even resize this virtual server. So for example, you need it today maybe with like 8 CPUs and 16 gig of RAM, but maybe you see that you need extra resources, right? So you can increase what we call scale up. I can add resources to my EC2 instances if I want, right? So I need to add more memory and more CPUs. So can I do this? Definitely yes. I can resize my compute capacity. And then if you remember, auto scaling groups. So let me tell you, or let me remind you, with auto scaling groups, remember that we can do the sizing on AWS based on the average and not based on the peak. So I can start with like 3 instances, and then I can monitor something like the CPU, and I can specify a certain threshold, for example, 80% of utilization. If I reached 80%, then automatically this service called auto scaling group will scale out. Remember? And this scaling out can be completely automated. So you specify this threshold, for example, and it can scale out, or when the load goes, it can scale in and terminate these instances. The name of the service itself, it's called ASG, or auto scaling groups, which is increasing, scaling out, or decreasing the number of instances. And now the question comes, if I have multiple instances, right, how do I load balance between them? I can have one instance serving all of my customers. But what if this instance fails? Definitely, no one will just rely on one server. So everyone relies on multiple servers in order to serve my customers. Now, how do I load balance in between these servers? We have what we call a load balancer, right? So very simply, clients coming from the internet, they connect to the load balancer, and the load balancer will distribute the load across my instances in this way, right? And this is the load balancer. So this is, we call it ELB, Elastic Load Balancer. So Elastic Load Balancer, that is the name of the service that is doing load balancing or load sharing, or very simply distributing incoming traffic. And then something very nice, one of you mentioned this at the beginning of the training, what we call serverless. Can you please put for me on the chat if you heard this term before? Serverless. Can you put it for me on the chat if you heard serverless concept before? Very good. I just want to see if you heard it before or not. I'm going to re-explain it. So what do you mean by serverless? So serverless, very simply, it means if I don't have a serverless, this means that I will power on my EC2 instance. This is my virtual server. This instance will have an operating system. And then at the end of the day, I have my application running inside this server. Fine. The application is very simply what? The application very simply is some lines of code, right? The application is very simply some lines of code. So when someone is connected to this EC2 instance, for example, let's say he's accessing this web server. So I execute these lines of code and then I present this customer the web page, right? So with the concept of serverless, what will happen here? Serverless means you don't need to provision this server. All what I need from you, just upload for me your code. And then tell me what is the trigger of this code. So in this example, what is the trigger? If someone is coming to do HTTP or someone is coming to port number 80, right? Port number 80 is the web port or the HTTP port. So this means that in the serverless compute here, I just need to upload my code and tell me what is the trigger so AWS can trigger these lines of code. So now the question, is this code running on infrastructure? Definitely yes, there is some infrastructure here. But do you need to manage or to provision this infrastructure? And the answer is no, right? So very important here. Whenever I say serverless, the serverless means that I don't have infrastructure? No. Serverless means you still have infrastructure, but you don't manage. You don't need to provision the infrastructure here. All right? So to answer Tabasso's question here, serverless versus containerization, is it the same? No, it's not the same. So here, serverless means you just need to upload for me the code. Containers is something different. I'm going to talk about it just in the next slide. So here, I need to manage and provision this EC2 instance. So I need to have the EC2 instance. Maybe I need to go and update the operating system to the latest patches, make sure it's secured. So I manage the complete instance plus the code. And to make it even very simple, now, do I need to, in some of the cases, do I need to manage the infrastructure? In some cases, all what you need to do is give me the code and leave this to AWS to provide for you the infrastructure needed for you to run this code. So again, serverless, it means I still need infrastructure, but you don't need to provision this infrastructure. Is this concept clear? And whenever we say serverless compute, this is the Lambda function. So Lambda is the name of the service that is providing serverless compute, because we can have other option of serverless in other services as well. Is this concept clear? Serverless compute. Any question about it? This is the serverless. Very good. And this is the serverless that we have here. And now to Tabatsu's question now. Now, what about containers? So let me give you a very high level about containers here if you don't know about the concept of containers. And why do we need this concept of containers? So for the containers, and it was a big revolution, especially for developers, because imagine if you are a developer and you're developing a certain code or an application, for example, on a Linux environment. You develop your application, you tested your application, everything looks brilliant. Now you're taking this application, you want to put it in production, but maybe the production environment, for example, was a Mac. You start working with the application and the application is not working. And then you say, how come? I had my application working here. I tested my application several times. It was working perfectly. And now when I moved my application to a different environment, it's not working well. And the answer was, this is because of some dependencies. These dependencies, they were installed here and they are not installed here. So you need to install the dependencies first. And that's what we did with the containers. So with the containers, I have my container, which is the application that I want to run with all the dependencies and all the libraries in just one version here. So now if I have this container and this container is working on Linux, it means that it can work anywhere else because I have put inside this container all of the dependencies, all the needed libraries for this container to work, right? So let me give you some names here. What kind of container you can run on AWS? This is called Docker containers. That is the name of the software platform where it can run containers. This is to run the containers. How can I manage containers? How can I orchestrate like multiple containers on multiple servers? And this is where we have something like Kubernetes. So this might be a bit technical for some people here. So Docker is the name of the software platform to run containers, and Kubernetes is the name of the management software, right? So why am I explaining this here? Because we have from AWS, we have from a management perspective, we have two options. Let me put it here. This is from container management. Container management. If you just remember what I just mentioned was something called Kubernetes, right? And this is a service in AWS called EKS. Elastic Kubernetes Service. So what is this EKS? This is the service that I need to manage my containers. And then we have another service called ECS, Elastic Container Service. So if you're already working on premise with containers and you are having Kubernetes, then moving into the cloud, you can go for EKS because you're already working with Kubernetes, so you can get this as an EKS or Elastic Kubernetes service. If you're starting the cloud from scratch, you don't have containers up and running already, then you can go for something much more simpler, which is ECS, which is a service from AWS to manage and orchestrate your containers. All right, so let's go back here. So in this slide, from a very high level. Again, in this level, since this is the first introduction for you to AWS, that's the first course that you have. You just need to understand the terms. That's it. You don't need to go into any of details of this. I need to understand from compute perspective. What do I have from AWS? We have an EC2, which is like a virtual server. You can have serverless using something called Lambda, or if you run containers, you have two options, either EKS or ECS. So here we even put just ECS. But you need to understand that there is another option called EKS as well if you have Kubernetes, right? For the people who know about containers, they might understand this part better. So this is to run applications on managed containers cluster, right? That is the ECS. Any question about compute services? Any question about the compute services? Is it clear with everyone? All right. So the benefits, definitely, it's elastic. We mentioned this elasticity with auto-scaling groups, right? It's very flexible. I can start with the sizes and then I can resize my compute capacity here. Definitely, it is secured, either from AWS to secure the physical proximity, or from you when you are configuring the configuration and the firewall parameters, for example. And definitely cost reduction because you only pay for the capacity that you used. And from a sizing perspective, I don't need to size it based on the peak. And that's the benefit of having the cloud. All right, number two is the storage services. And for this one here, let me give you a high level of storage as well. This is to help you understand these services and where do I have these services. So from the storage, this is in general about the storage in the storage industry right now. I can divide the storage into three families. I can divide the storage into something called block storage and something called file storage. And the last family, it's called object storage. Have you heard about these terms before? Not sure if you are into the storage industry or not, but in storage today, even in the on-premise, I can divide the storage families into three parts. What is each and every part? Very simply. So what is the block storage? Block storage, very simply, if you have your EC2 instance, this is like the hard drive of your instance. This is like the hard drive of the instance, and we call this EBS, elastic block storage. So what is EBS? EBS is like the hard disk, the hard drive attached into your EC2 instance. All right, and then for the file storage in general, what is the file storage? Let me give you an example which you have definitely seen in your network. With the file storage, this is if you have a file share like this, you have your corporate network and you have a server where you have a file share, which is something like this, //10.1.1.1, for example. I'm sure that you had this in any of the previous companies you used to work for. If you want to access a certain shared folder where you have certain files that everyone has access to, for example, right? So I have here a shared folder where I want to share this folder with everyone. Here, with my hard disk, the hard disk was only for this EC2 instance, right? What if I want to have a storage that can be shared between multiple EC2 instances? And this is what we call file storage. And the service name of the file storage here, it's called EFS, Elastic File Storage. And for your information, this is for the Linux machines. If you want something for Windows machine, this is called FSX. This is for the Windows machines. All right. And then finally, for the object storage. In object storage, we call it, this is a flat file system. And that's why this is the most scalable storage that we have. And that's why we use the object storage in the internet data, because you can see the amount of files that we have for the internet that we have right now. And something very important to understand about object storage. Object storage is for this specific type of storage called worm, if you heard about it before. Worm means write once, read many. Write once, read many. So this is mainly for the kind of files that they don't change with the time. Like what? Like pictures, like videos, right? And this is specifically why object storage is the kind of storage I need, for example, for the internet, for something like the social media, for example. Because with the social media, you have these kind of files, but these files, they don't really change, right? Like pictures and like videos, for example. So these files are uploaded, and once they are uploaded, they don't change, right? You don't want to change a picture with you and someone else, for example. So the object storage is mainly for warm kind of data, which is write once, read many, and can also be for data archival and backup recovery, right? It can also be for archive and recovery. And the service name from AWS, it's called S3. The service name of AWS providing this kind of storage, it's called S3. All right, this is just to give you a map of the next slide, which we're going to see it here. All right, so EBS, object storage, EFS for file storage, S3 for block storage. All right. So for the storage services, we have S3. Now you understand. So S3 is the name of the service that is giving me object storage. And it can have, it's very, very durable. It can go up to 11 nines of durability. So theoretically speaking, you should never lose anything inside the S3. And then we have something called EBS. I guess now you understand. EBS is like the hard disk and the hard drive of your EC2 instance. And then for backup and archive, we have something called S3 Glacier. So it's a level, or it's a storage class of S3. So it's a type of S3 that is a very cost-effective storage. This is mainly for what we call archiving and backup. And this is to replace what we call tapes. Have you seen tapes before right now? Where you're doing a kind of backup and archive, where you have physically tapes, right? Where you can see when you can have a backup of every day, for example, inside the tape, right? I can replace the tape with a cloud backup and archive options here, and this is called S3 Glacier. And then we spoke about EFS, if you remember. What was EFS? It was the file storage. So Amazon Elastic File System, this was the file storage. If I need multiple EC2 instances, all of them to share a certain storage. All of them to share a certain storage. I can have this EFS, but we mentioned EFS is only for Linux. You can have FSX. This is if you have Windows machines. And finally, if I want to synchronize data between my on-premise and my cloud, so if this is my on-premise and this is my cloud, and I want to be synchronizing data and storage in between on-premise and the cloud, there is this service called Storage Gateway. So Storage Gateway is the service that will let me kind of doing a replication between my on-premise data center and between my cloud infrastructure. So please look at the slide here. Let me know if anything is not clear. From storage services, we have mainly three families. We spoke about the block storage, we spoke about the file storage, and we spoke about the object. And we mentioned the name of every service that I can do with the storage. Any question about this slide? All right. So benefits, very simply, it's very elastic for something like S3. You can keep on adding objects, theoretically speaking, till the infinity. I don't have a limitation on the kind of storage that you need to have. It's very flexible. You just choose the volume type or the storage type that you would like to do. And in order for this to be secured, what do you need to do? I need to encrypt. And the question here, encryption must be something that is configured by the customer. So AWS definitely can help you in providing you the encryption keys, but again, it's the customer responsibility to have his application working to encrypt the data. And here, you only pay for the storage that you used, right? Which is the on-demand model that we explained in general on the cloud. All right, and then we go into the database. So let me also explain high level of database in case you don't know about it. For databases, mainly we have two families. If you are familiar about databases, we have something called relational database and something called non-relational database. This is the two types of families that we have for the databases, right? So what do I mean by relational databases? Relational databases, it means I have multiple tables that they have a certain relation. That's why it's called relational. And how do I query data from these tables here? I have something called the SQL language, right? So the SQL language, this is to query my relational database, right? In the non-relational database, some people, they give it another name called NoSQL, which means here I don't use the SQL. I use something called the APIs in order to get these data. And it's a key value pairs tables. So that give the tables, they don't have a relation in between each other here. But for the relation, what do we have? We have two options. If I want to do relational databases on AWS, I have two options. I can do what we call self-managed. Self-managed means what? How do you do today a VM that will have a database? So you have your virtual machine, for example, today. That is maybe a Linux virtual machine or maybe a Microsoft if you have Microsoft SQL. So you have the VM operating system here. And then you run your database engine. On AWS, I can have exactly the same. So I can have my EC2 instance. So instead of a virtual machine, this is an EC2 instance. It has the operating system. And then you install the database engine that you want. Whether you want Oracle, whether you want Microsoft SQL, these are the enterprise flavors, or whether you want something like open source, like MariaDB or Postgres or MySQL, for example. So you can do it this way. But with the self-managed, what do you need to do? I need to provision the EC2 instance. I need to make sure this operating system is updated to the latest patch to make sure I don't have any security vulnerabilities, for example. And I need to install this database. I need to make sure that I have the enough storage of this database. I am the one responsible for the replication of this database. I am the one responsible to take snapshots of this database. So you're going to see here the database administrator has lots of tasks that he needs to do. I can do on AWS, instead of doing a self-managed where I do multiple tasks, I can do here what we call, I can go for an option called RDS, Relational Database Service, which means here in this case, you don't need to provision an EC2 instance and do all of these tasks manually. All what you can do, you can tell me, all right, AWS, I will need a database engine that is, for example, Oracle, that is Microsoft SQL, for example. That's it, right? But at the end of the day, this database is running inside a certain EC2. But the intelligent thing here, you don't get access to this EC2, which means you don't need to worry at all about the operating system patching and updates. It's done by AWS. You don't need to worry. Okay, where are you lost? From which part you were lost? جوه الحاجة. From the self-managed, because I tried here just to give you. Okay, so let me explain the relational database. This is the relational. How do I have relational database on AWS, right? I have now my database on premise. It's running now on premise, and I want to migrate into AWS. Okay? How do I migrate into AWS? I can migrate into two options. I can migrate either using self-managed, and self-managed here means you are going to do everything yourself. That's why it's called self-managed. So you need to provision the EC2 instance. And then you need to go to the operating system and make sure this operating system is updated. So to protect from any security vulnerability, for example. And then you need to go and install your database engine. This is the meaning of self-managed. And that's what you do, by the way, today in your on-premise. Today in your on-premise, you need to have your virtual machine, and then the database administrator is the one responsible for this specific virtual machine, install the operating system, install the engine on this one. So if I want to do migration on AWS, I can migrate using exactly the same model. But if I migrated using the same model, what's happening here? If I migrated using the same model, this means that I need to provision a lot of tasks here. I need to provision the EC2 instance. I need to update my OS. I need to install the database engine. And I need to take care about the snapshots of this one, the storage about my database, for example, right? Versus on AWS, right? So I can do it in a self-managed way, or AWS is offering something very nice called RDS. And RDS simply means you don't need to worry about the unnecessary tasks. Like what? Like provisioning the EC2 instance, upgrading the OS, installing the database flavor. All what you can do, just tell me what engine do you want. So here you're going to see that we have multiple available engines from AWS, and we have all of them. So we have Oracle, we have Microsoft SQL, and this is mainly for the enterprise grades, or we have MariaDB, MySQL, or Postgres. These are the flavors of databases, for example, right? Just let me know which one do you have, and I'm going to go and do everything from these tasks on your behalf, right? In order to save you lots and lots of time here and unneeded tasks here. I don't need to pay attention to the operating system and the patches, right? Let AWS worry about this in the back end, in your back end, on your behalf, right? So here in this case, you just go to AWS and get a managed RDS and just specify for me what is the flavor that you want. Does it now make more sense? Because I try in this section, Gubelahan, to make sure that even if you don't know about databases, just to give you a bit of a background about databases here. If you don't have an experience, what is relational, what is non-relational. Also, we can benefit from the AC explained before on the RDS, right? Definitely right. So when you are configuring Hamza, your RDS, with just one click of a button, there is one option here. If you want this RDS to be something called multi-AZ, just a check in the box here. If you checked multi-AZ, AWS will create for you two RDS instances. One of them is going to be the master, one of them is going to be the slave. And if the master fails, automatically the slave becomes the main one. If I'm doing this on self-managed, I need to do this manually. Another question, is the edge available for RDS too? No. The edge is mainly for services like the CloudFront, Shield, and WAF, but not for RDS. The edge is for services like CloudFront, Shield, and WAF, and maybe some of the firewall services, but not for the RDS. For the RDS, you need to have an availability zone. Yeah. All right. Is this clear? Gubalahan, any question? Is this clear now? Okay, very good. Hamza, any more questions? Okay, very good. So let me also add something here when we talk about the data bases that we have. So in most of the cases, you will find people with Oracle and with Microsoft SQL, but this can be expensive because they require licenses, and you might feel that you are bounded to these vendors because of the licenses, especially for something like Oracle. So other customers might go for something like MySQL or Postgres, but MySQL and Postgres, they are open sources, so you might not get like a proper support. But they are definitely much cheaper than Oracle and Microsoft SQL. And because of this, in AWS, we have created another flavor called Aurora. So Aurora very simply combines both of best features that we have between Oracle and Microsoft and MySQL and Postgres. So Aurora provides an engine, and this is an engine specifically made by AWS, that is backward compatible with Postgres and MySQL. It is 5 times faster than MySQL. It is 3 times faster than Postgres, but offering an enterprise-grade database flavor with enterprise support coming from AWS. So it's combining best of both worlds here, from Oracle, Microsoft SQL, and MySQL and Postgres. And this is called Aurora. So what is Aurora? Let me tell you something here very interesting, that for someone like Samsung, and I'm going to show you this case reference here. Samsung migrated 1.1 billion users from Oracle into Aurora in almost 18 months. Samsung was a big Oracle customer and migrated 1.1 billion users from Oracle into Aurora. So Aurora is not something that is like on the small scale, right? I have shown you example of Samsung, and definitely we have much more examples of people migrating from like Oracle and Microsoft SQL because of the very high cost into something like Oracle. So as per the relational database, any question about this slide? Anyone feeling lost or anyone feeling anything not clear? I just tried to give you a bit of a background about databases if you don't have this background. Any question? Okay. So for database services, as we explained, I have something called a relational database, which is these two. So from the RDS, this is an AWS managed engine to you. You don't need to do anything from scratch here. The engine will just be up and running for you here. And we have all of the flavors that you want: Oracle, Microsoft SQL, MariaDB, Postgres, MySQL. And one option of the RDS is what? Is Aurora. One option of the RDS is Aurora, and this is compatible, as I mentioned, with MySQL and Postgres. So people liked MySQL and Postgres, but they are open sources, so they are not very reliable on MySQL and Postgres. And that's why now Aurora is combining the best of both worlds here, enterprise flavor with the price and the cost of open sources. What about the NoSQL? Remember, this was for the relational. What about non-relational? So Amazon DynamoDB, this is an example of non-relational database. All right? So from the relational, we have the RDS with all of the engines we have. From non-relational, we have the engine name, it's called DynamoDB. And then finally, now if I need to enhance my database performance, right? Usually, how do I enhance it? Remember, with the CDN before, I can enhance the performance using something called caching. And that's why we have something called Amazon ElastiCache. And this is like a cache for DynamoDB. So now it will act in the middle between the application and the database, so that if I can see these queries before, I can serve it faster, right? And that's the meaning of caching. Remember, I have seen this before, so I can serve this much faster, right? And this is ElastiCache. Look at the slide, please. Do you understand it? Do you have any question about what we have in the slide? I tried to explain a bit of a background here in case you don't know about the families that we have of databases. So relational databases, non-relational databases, RDS from AWS, or DynamoDB for the non-relational. Any question about these ones? Question. I tried before to use DynamoDB, but didn't totally get it. Could you please give examples? Of course. So very simply, Hamza, DynamoDB, this is not like the RDS flavors that you work with every day. You need to have the use case of your application here requesting NoSQL database. So DynamoDB is a NoSQL database. So if you have worked before with something like MongoDB before, which is a non-relational database, you can very simply understand the use case of DynamoDB. It's like the equivalent to something like MongoDB on the cloud, with the flavor of AWS itself. Okay, very good, very good. So what are the benefits? We explained this. It's managed, and managed means there are lots of tasks that now I can offload my database administrator from doing. It's very reliable because automatically, if for example you created something like Aurora, I'm going to create 6 copies of the database in 3 availability zones automatically on your behalf without you creating anything. Once you create an Aurora database engine, automatically I will create 6 copies of these engines across the 3 availability zones, right? And definitely it is elastic and it is very secure. Fine. What about security? You need to understand that security, we call it in AWS the job zero, or the highest level of priority in AWS goes to the security. Why? Because imagine if I can tell you that I have these wonderful services that I have on AWS, I can give you this kind of cost reduction, but sorry, it's not very secured. No one will come to AWS, right? And that's why I need to have everything here very, very secured. So how can we secure? Let's take like three options. We have definitely, why do you call it in AWS? What do you mean? I didn't understand the question, Hamza. What do you mean by why do you call it in AWS? As you said, first we call it, security. So security is our highest priority. That's what I was explaining. So I was saying that for security, in AWS, security is our ultimate priority. It's priority number one for us. We call it job zero, which is how can we make AWS secure for our customers, right? And so this is getting the highest priority in AWS. And we can do security in multiple areas here. I'm going to mention, as per this training, just three of them. The first one is called IAM, Identity and Access Management. This is what is IAM very simply. You are going to have your infrastructure. Your infrastructure will have EC2 instances, will have RDS databases, will have maybe S3 for storage. And then you have your team managing this infrastructure. So the question is how they can manage and what kind of control do they have? So what do I want to do? I want, for example, my server administrators to only manage EC2 instances. And I want my storage administrators to only manage, for example, the S3. And my database administrators to only manage my database. So with the concept of the IAM, you are very simply setting user roles and policies. What are you allowed to configure and what you are denied from even monitor or configure. So for example, for my server administrators, they will only get access to my EC2 instances, and that's it. They don't have any access on the storage or on the database. Whether, for example, my operation team, they cannot get write access on anything because they cannot change the configuration, but they can very simply check and operate and monitor my services. Did you get this? So the IAM is identity and access management. This is creating users and roles, multiple roles, and every role with his own guidelines. And then AWS Directory Service. From the name, this is very simply like a managed Active Directory. So if you want, you can rely on your own on-premise Active Directory, or you can leverage something like this directory service from AWS, which is a managed Active Directory in AWS. And finally, what we call HSM. What is HSM? HSM, this is if you need your keys for encryption, and in some organizations, they need to have the keys locally on site. They don't want to store the keys in the cloud. So Cloud HSM, by the way, is like a server that you purchase from AWS, but this server is inside your physical location. It's inside your organization. And on this HSM server, this is where I have my encryption keys. Because I cannot, based on my compliance, I cannot have the encryption keys on the cloud. As per my compliance, I need to have my encryption keys locally inside my organization. So again, HSM is a physical server that you install physically inside your organization, but it's getting all the keys stored inside this physical server if you have a customer with compliance of having this inside his organization. Is it clear? This is to meet the compliance requirements for data security keys. So if an organization is using cloud HSM, are they using a hybrid cloud deployment? No. So cloud HSM, very simply, Kyle, it means that these users are using encryption in the cloud, all right? But they have a certain compliance and regulation policy that they cannot have the encryption keys stored in the cloud. So everything is in the cloud, right? I'm not having any cloud environment or hybrid environment. But I have a regulation that says do not store the keys in the cloud. Store the keys locally inside your organization. And this is the cloud HSM. It's a service, it's a server. No, it's not like OTP. OTP is for whenever you are doing authentication, Hamza. HSM is to store the keys that I have for encryption. So it's different. It's not like OTP. OTP is a one-time password if I'm doing authentication. Cloud HSM is not for authentication. Cloud HSM is to store my encryption keys. But I have a regulation that the keys cannot be in the cloud. The keys must be inside my organization. That's the compliance. Kyle, is it clear? Okay, very good. So again, for these security services, if I want to be compliant, and every customer has different compliance and regulations, definitely to reduce my cost. It's very elastic and you can scale very quickly, especially that if you need lots and number of keys for multiple encryption mechanisms. And again, the key here is to make it secure. Definitely the key here is to have it secure. All right, more and more services, management and governance. In order for me to have my cloud, and in order to have this cloud running in a perfect way, the key word is to do what? Is to monitor, right? The key word to make sure that my cloud is working as expected, I need to monitor, right? And the service that is helping me to monitor all the metrics that I have for my infrastructure running, it's called Amazon CloudWatch. That's a very, very, very important service. So CloudWatch is like a single pane of glass where you can see, definitely also good for debugging, of course, because you can even put some logs that can go into CloudWatch where you can see it. Yes. So Amazon CloudWatch is very good for monitoring, like a single pane of glass where you can see dashboards and you can configure and customize these dashboards. For example, you want to see your EC2 instances. You want to see your storage utilization. You want to see your database, for example, performance, right? From where I can see it from this service called CloudWatch. And then another very important service called CloudTrail. And CloudTrail, this is for auditing. What do I mean by auditing? Let's say someone deleted an EC2 instance. Someone deleted an EC2 instance. How do I know which user deleted this EC2 instance? I need to check all the API calls. API calls, anyone who is like powering an EC2 instance, resizing an EC2 instance, deleting an instance, everything is an API in AWS. So with CloudTrail, I am logging everything anyone is doing. So in case in the future something happened and maybe someone deleted an EC2 instance, I can go back to CloudTrail and I can check the logs. All right, on this day, I can see this user deleted this EC2 instance. And then you can ask him, okay, so why did you delete it? So for example, he can say, yes, this service was not performing well, for example, and this is why. That's the report of the EC2 instance. And that's why, for example, I deleted the instance because I powered on another one, just as an example. But the CloudTrail is for auditing. All right. And then another service called Systems Manager. Imagine if you have hundreds of EC2 instances, right? And then these hundred of EC2 instances, they are running a certain Linux flavor, for example, and then you discovered that there is a security patch that you need to install on this Linux machines. So what do you need to do? I need to install this on 100 instances. Does it make sense that you will go to one by one and install it? Definitely not, right? So there is this service called Systems Manager, so you can automate your operational tasks here, right? So I can say that's the task, and I want to deploy it on this amount of servers, right? So System Manager will go and deploy it on your behalf to X number of servers, whether you have like 10, 100, or 1,000 even servers here. And then something called cloud formation. What is cloud formation? If you know about this term, have you heard about this term before? Infrastructure as a code. Can you tell me on the chat if you heard about this before? Infrastructure as a code? Yes or no? Yeah. So very simply, what is this term here? Imagine if I have my infrastructure. I have my firewall and my load balancer. I have my EC2 instances, and then I have my database, right? I have a big and a complex infrastructure. And let's say I want to deploy this same infrastructure in another region. Will I go to the second region and configure everything manually from scratch, like a load balancer, and then EC2 instances, and then an ASG, and then an RDS, and then S3? It will take me lots of time, right? So what can I do? I can do something very intelligent. I can save my infrastructure as a template file, very small file that has all the configuration. And then I can go to a service called CloudFormation, and I can pass to this service my template file. And it's going to configure everything from scratch on my behalf to automate my cloud infrastructure creation here. Did you get this? So for anyone who knows about infrastructure as a code, outside of AWS, there is something called Terraform. Just maybe you heard about it before, something called Terraform. Terraform is the infrastructure as a code outside of AWS. And in AWS, the service that we use is called CloudFormation. All right. And again, AWS auto-scaling, if you remember, what was auto-scaling? ASG. It was the service that is monitoring my EC2 instances. And if there is anything, simply what do? I initiate or I scale out extra EC2 instances here. All right. Any question about this slide? Management and governance services that we can have on AWS. So this is providing a reliable kind of services, right? It's very easy to use, like this CloudWatch, for example, or Cloud Trail. Just clicks of mouse, and then you can have everything ready for you to monitor. So you can collect and track metrics, maybe like CPU utilization, like network in and out, for example, that can help you to manage your infrastructure. All right. We finish the network services and then we go for our second break. For the networking services here, right? So I want to have my infrastructure on AWS. So what do we have? The first example is called Amazon VPC. What is the VPC? If this is my AWS cloud, When you create a VPC, the VPC is your virtual isolated area inside AWS. So the VPC, it's virtual private cloud. So this is where you configure your load balancer. You configure your availability zone. So this is availability zone number 1, and this is the second availability zone. I'm going to have my web application. I'm going to have my EC2 instances like this. But I want it to be in multiple availability zones. So AZ1, and this is AZ2. So I have EC2 instances across multiple availability zones. And I have the database, for example, here. So this database, and the second, this is the secondary database, and I have this kind of synchronization. So where do I have these instances? They are in my VPC, virtual private cloud. It's like your isolated area inside AWS. This is the meaning of your VPC. And then that's the first one here. You want to build a virtual network, a virtual infrastructure inside AWS. And then something called direct connect. What is direct connect? If I want to connect my on-premise data center, I want to connect it with my VPC or my AWS cloud. How do I connect my on-premise into AWS cloud? Let's say, for example, I have my database here, and I want to synchronize my database between my on-premise and AWS. How can we connect the on-premises into AWS cloud, right? So we have two options. The first option, I can use the internet, and I need to create something called a VPN. So VPN is a virtual private network, very simply. If I want to connect two places together, right? But this is over the internet, and I don't want anyone to understand what am I using here. So this will encrypt the traffic in between my on-premise and my AWS. But because this is over the internet, I cannot go to very high speeds, right? The maximum speed here is 400 meg. 400 meg. What if I need high speed of replication between my on-premise and the cloud? This is what we call direct connect. So direct connect means it's a physical connection. You connect physically your router to your telco service provider, and the service provider is connected to AWS. And here you can get speeds like 1 gig or even like physically 10 gig of speed. But this kind of direct connection, it takes few weeks to be up and running. So if you ever seen it in a cloud practitioner exam, you need to have a connection between your on-premise and the cloud. But I need something very quickly, then you go for the VPN. If you want something that is higher speed and you have no problem to wait, then you can go for direct connect, right? So again, in the slides, it's only mentioned direct connect, but I mentioned for you both options. The VPN, which is over the internet, but you cannot go to very high speeds. If you need to go to something like 10 gig, for example, you can go for direct connect. And finally, the final service. Do you know something called DNS? And can you tell me what DNS is doing? Do you know this service called DNS? Anyone can say or can mention what is DNS doing? This should be a very famous service, right? DNS. What is DNS doing? Resolving names into what? Yeah, it's like a phone book. I like it. Yeah, resolving names into IPs, right? So, for example, you go to something like facebook.com, right? Internally, for networking, I don't know names. I know something called IP addresses, right? But for users to be easy, exactly. But for users to be easy, right? You remember facebook.com better than remembering 192.168.10.253, for example, right? And this entry that we have, the database that has the IP of facebook.com is this XXX is called DNS. Fine. In AWS, we have a service called Amazon Route 53. And Route 53 is providing a managed DNS service. Route 53 is providing a managed DNS service. Is it clear? Let me ask you this question. Can anyone tell me why is it called 53? Why is it called Route 53? Any clue? Why is it called 53? Because I'm not sure if you know about this or not, but the DNS to work, the port number of DNS is port number 53. That's why it's called Route 53. All right. So again, like all what we have mentioned before, it's very elastic, extremely easy to use, right? How we can access the console is extremely easy. Definitely very secure on how do I have this kind of communication, either over the internet through the VPN or over direct connection. And definitely reduced cost. For example, to create your VPC, the VPC itself is for free. You just pay for the resources that you will have on the VPC. All right, so if you have understood this, can you please do for me this kind of knowledge check? Just a quick check to make sure that we understood the previous lesson 100%. So let's take it one by one. What is secure, resizable compute capacity? Look at this and tell me, what is the compute capacity here? Can anyone mention? What is the name of the compute service? EC2. Do you all agree? Very good. Do you all agree, right? So, secure, resizable compute. This is very simply, it's the EC2. Very good. All right. AWS Cloud Resource Monitoring. What was the name of the service? Very good. Very good. Monitoring is what? This is CloudWatch. Monitoring, very good. Very good. Thank you to everyone who wrote it. It is CloudWatch. All right. Database backup, patching, management, replication. Which service? Thank you so much. This is the RDS, right? This is the managed database called RDS. Very, very good. End users routing to internet application. If I have two applications, how do I route my users to multiple applications? This depends on their IP addresses, right? How do I get the IP address? Any clue? Exactly what we just mentioned. It's Route 53, right? It is Route 53. And finally, internet storage for backups, video, and static content. What is the internet storage? Very good. This should be what? Yeah, internet storage or object storage, this should be S3, right? So I hope that this is clear, right? I hope that this slide is clear with everyone. So before we go into our second break, any question? Any question? Is this concept clear now? Any question? Does it make sense to you? Anyone has any question? All right, so I guess it's time, very deserved break right now. So it's time for the break. So let me put another 15 minutes here. Then we go into the break and we come back. See you in 15 minutes.